Today we're going to be focusing on graphing linear systems. So a system of equations is two or more related equations that have solutions in common. So a linear system is a system with no more than 1 degree. An independent system is a system of equations that has exactly one solution. Dependent system is a system of equations that has an infinite amount of solutions. And an inconsistent system is a system of equations that has no common solution. So let's take a look at some examples. First, we want to solve this by graphing, so we want to put it in slope-intercept form. So for this first equation, 2x plus y equals 5. We want to get y by itself, so let's subtract 2x to both sides. So y equals negative 2x plus 5. And then the second one, we could add x to both sides. So if we solve this by graphing, this first equation, we have a y-intercept at 5, and we have a slope of 2. So if we graph this, here's that one. So now we can graph y equals x plus 2, so we have this y-intercept of 2. We're going to be going up 1 over 1. So the solution to this is where they intersect. So right here is where they intersect, so our answer is 1, 3. That is the solution to our system. So in example 2, we want to determine if they're independent, dependent, or inconsistent. So let's graph them and then identify. So for this first one, we can subtract 3x to both sides. So y equals negative 3x plus 5. Second problem, we subtract 5x to both sides. And then we'll have to divide everything by 5. So y equals negative 3x plus 2/5. So if we graph the first one, we have a y-intercept at 5, slope of 3. And we can connect those. And then 2/5, negative 3. So since these have the same slope, we know they're parallel. So since they never intersect, that means it's inconsistent. Alright, so this one we already have solved in slope-intercept form. So let's add 4x on the second one to both sides. 2y equals 4x plus 6. Divide everything by 2. So y equals 2x plus 3. If you notice, same exact equation, so when we go to graph both of them, we're going to be graphing the same equation. So since it's the same equation, this is going to be dependent. So let's look at the third one. We can subtract x to both sides. Divide by negative 1. So y equals x minus 5. And then this one we can subtract 3. So y equals 2x minus 3. So if we graph our first equation, we're at negative 5. For y-intercept, we have a slope of 1. In our second equation, we're at negative 3, with a slope of positive 2. So as we can see in this graph will eventually intersect one another, since they will intersect. It's an independent graph. Alright, let's flip to the back side. Suppose you are going on vacation and leaving your dog in a kennel. Kennel A charges $25 a day, which includes a one-time grooming treatment. Kennel B charges $20 per day and a one-time fee of $30 for grooming. So let's write an equation to represent the cost for days that your dog will stay at each kennel. So let's look at kennel A. So kennel A, it will cost $25 per day. And then kennel B, the cost is $20 a day plus a $30 grooming charge. So let's graph both of these equations. So if we look at our graph, we can label this the days, and here's our cost. So kennel A, at 0 days it's 0. 1 day will cost $25. 2 days will cost $50. 3 will be $75. 4, $100. 5, $6. Good. Now that we have that, let's graph for kennel B. So kennel B will be charging $30 for the grooming. So for 1 day, it will cost $50. And then day 2, so remember we're going up $20 each day, so it's an extra $20 for the 4th day. That red dot should be there. So find the number of days for which the costs are the same. So we can tell at day 6, it'll cost the same. So at day 6, no matter which kennel you're at, it's going to be $150. So if our vacation is a week long, so 7 days, which kennel would we choose? Well, judging by our graphs, after day 6, kennel B ends up being the cheaper place to stay. So we want to choose kennel B because after 6 days, the price will be cheaper. We're using that based off of our graph.